Hey, it's Alex Williams of the News Stack here live in San Francisco at the PagerDuty Summit, and I'm lucky to be joined today with the co-founder of PagerDuty, Alex Solomon. How are you?
Hey, Alex. Doing really well. Thank you for having me on the live stream.
Yeah, it's nice to see you here. I mean, this is a time of scale in this world, isn't it?
Absolutely. It's an amazing event this year. We have, I think, around 800 people joining us, so it's almost double what we did last year.
Yeah.
It's exciting.
I was in the keynotes this morning, and I was asking you prior about your career when you started, and you said 2005, and I was thinking about what Aaron Levy was saying about 2005 with one server. But when you started your work, where did you start in a small business, or what was it, or did you go to what is the trajectory of your career? I'm curious.
Yeah. So I worked at Amazon up in Seattle as a software engineer. Yeah,
that's where you started.
That's where I started. Yeah.
Oh, really? Okay.
Yeah.
So you started there, and so 2005, and the topic for our discussion today is event triage and team communication. I'm curious about back then. What was event triage? What did that look like, kind of in those early days when you were starting your career?
Sure. I mean, this is before public cloud and AWS. Actually, Amazon launched AWS while I was at Amazon, but I was on a different team. Was not on the AWS team.
Right.
So back then, bigger companies like Amazon, they had to build their own tools for monitoring and managing events at the scale that Amazon was back then, and now it's grown tremendously since. So it was more of a do-it-yourself, build-it-in-house type of endeavor. And there was some of the bigger vendors like your HPs and IBMs and BMCs that were serving the market as well.
So you were really in the early days learning about these concepts of event triage, weren't you?
Yeah, absolutely. I mean, I had the good fortune to be at Amazon when they were, going through the scale and launching AWS, and being one of the first businesses to really grow up on the internet. And due to their scale and due to the fact that they also were one of the early adopters of DevOps, it was kind of being in the right place at the right time and getting that DevOps education early.
So what did it look like then? What was event triage back in back in those early days?
Well, the way we did it at Amazon is tools built in-house. There were teams that build monitoring services. And as a software engineer, while I was there, we built a bunch of services. These are, microservices is what we call them today, but service-oriented architectures. Right. So Amazon was one of the pioneers of SOA. And each team was responsible for not just writing code, but testing that code, deploying it to production, and operating in production. And there were other service teams in Amazon that build some of the infrastructure and monitoring. So you can set up monitoring pretty easily for your services, and you can start getting events and alerts out of the monitoring tools. And those were fed pretty much into the ticketing system that Amazon used, which was based on Remedy and very heavily customized.
So fast forward today, and we're seeing more organizations adopt these practices, like effective event triage. I'm curious about, these issues that today that you're seeing, right? What are you seeing kind of in, that provides you context about how far things have come since you started your career in 2005?
Yeah, I mean, the world has changed tremendously since then in the last 12 years or so. Now we have AWS and public cloud and Microsoft and Google as well. And as microservices are very commonly used to architect systems, which means that these new systems that are being built today are distributed systems. They run on lots of different servers and boxes, and now we have containers as well. So things are getting easier to manage on the node level. in that you write a service and it plugs into other services, but then the entire system is a lot more complex and runs in a distributed environment where things can fail and do fail all the time. So you have to architect these systems for not just scale, but resiliency and failure tolerance. Like at any moment, your container or your server or your application or part of your application may go down, and you have to architect around that so that it's failure tolerant.
It's failure tolerant.
Yeah.
And that means you need to almost in some respects have that service-oriented architecture to work with that?
Absolutely, and then because of the surface area of these applications has grown tremendously, they produce a lot more events and alerts than they used to, 10, 12 years ago. And because this new environment running in the public cloud, things can fail at any time, or Amazon may do maintenance on part of their fleet, and you have to move your capacity to somewhere else. You have to design for things coming up and down all the time. So the volume of events and the volume of alerts that is being generated today has grown tremendously by factors of magnitude. So instead of just having humans be on the forefront of triaging all of those events and alerts, you have to have software systems to automate and filter out all the noisy alerts and noisy events and focus on the signal. The signal to noise problem is a big one. So the only way to get through all the noise is to automate.
So you talked a little bit about the surface area. Can you talk a little bit more about that in terms of the challenges that come with the surface area of these new tools?
Yeah, absolutely. So in terms of surface area, I mean, like the applications get more complex, and the functionality of these applications have grown. So when you think, even a company like Amazon, you think, oh, it's just a e-commerce site, so you just go and browse and you buy something, put it in the cart and check out. Well, actually, there's a lot of complexity underneath that in terms of recommendation engines that recommend products for you, right, and services that will display images for the products, right, and serving third-party sellers, right, for example. So there's a ton of software that's powering Amazon, and software is powering more and more parts of each component of a business.
So
that's what I mean by the surface area.
The customers who are consuming your API, right?
Yeah,
they have to think about all the dependencies in addition to that.
So you have all of these services or microservices, and they're all talking to each other, and you have to understand in this distributed environment who's talking to what. Because if one service or one microservice goes down, it might not be, the root cause might not be in that microservice. It might be based on one of the dependencies, one of the downstream dependencies.
Exactly. And
so if service A talks to service B, which talks to service C, and service C goes down, it can cause outages in A and B as well.
Right.
Yeah.
Right. I'll never forget this hilarious story. Someone told me they worked for a bank, and the bank, was very concerned about their policy, obviously, right? Their IT policy. And they decided that all this rogue use of Amazon Web Services was just going to stop. So they started unplugging things.
Wow. How did that go?
It didn't go well. Suddenly people were calling from all over the world saying, "What just happened?" Yeah. So the technology is one thing. It's the communications entirely another. What are some of the issues that contribute to the poor communication, right? What are some of the factors that you see coming into play that puts people into more of a reactionary mode? Yeah,
it's a good question. I mean, there's lots of examples of the set of best practices that we've evolved over the last 5 years has been, things have changed quite a bit. So in terms of communicating about, say, an incident or an alert, when you have a major incident where it's actually impacting a critical application, a business critical application, you want to make sure that the right teams get on it as quickly as possible, and only the right teams. Is one of the failures that we see is companies are afraid that this incident, obviously it is business impacting, so they decide to page everyone all the time. So you end up like paging 100 people, then they all jump on a conference call, and then 95 of them are not needed there. And communicating gets really hard with 100 people on a conference call, if you've ever tried it. So this is something that we focus on from a product perspective, and also from a best practice perspective. Get only the right people on the call in order to kind of streamline the incident response and resolution process. And streamline the communication, because you can't have 100 people on a call. It just doesn't work.
So let's back up on that a little bit, because that comes down to team dynamics, right? And it comes down to workflows, correct?
Yeah.
And it comes down to the communication systems that you have. So, how are you seeing all of these, these issues that can kind of rise up to create this ineffective incident response?
Yeah, I mean, so we definitely recommend setting up monitoring on all of your services is kind of table stakes,
right? And
then setting up the right alerts so that when you have something that's not a real problem, it should not alert. All alerts should be actionable. Actionable means if you get alerted about something, that there's something that you're responsible to do. In our space, you hear a lot about an engineer gets paged, they look at their phone and they see, oh, this is not a real problem. That is the perfect example of a non-actionable alert, the one that you can ignore because you know what it is.
Yes.
So it's important to spend time to tune your alerts so that you don't get these spurious pages that you don't need to care about. And then making sure that you page the right teams when serious or a major incident happens. And then once you do that they all get together into a single communication channel, and they can communicate and collaborate to resolve the issue as quickly as possible. So what we see a lot is a conference bridge and a Slack channel, both at the same time, where the bridge is used for real-time, chatter and talking, and the Slack channel is used to record what's happening and to copy-paste details of actions that folks are taking. So it's part of a best practice guidelines that we recommend for incident response in general, is that you have a dedicated role as part of the response called the scribe. So this individual, their job is to record what's happening. So on the conference call, if multiple people are talking and a decision is reached, write it down in the Slack channel so that later on you can find out what happened and create a timeline for the postmortem. And then also that if someone new gets looped into the call and they don't have any context, they can actually scroll through and get that context quickly from the Slack conversation.
So it's it's almost like creating an artifact of the issue itself.
Yeah, because I mean, people forget very quickly, especially when it's it could be in the middle of the night, or you're not going to remember all the details. But if you write it down in that Slack channel and record it, that's a good artifact to have.
So that's a best practice, right? And so when you think of best practices, for today's teams, and you're thinking about how these teams working at scale can implement them to communicate better, what are some of the things you're starting to see? What are some of the things you're starting to see, that are proving effective that are important for this practice?
Yeah, I mean, one of the things to avoid when responding to an incident, and you have multiple people in the response, is at times a bunch of engineers get on the call and there's nobody in charge. So people are just kind of looking around, and there's no coordination on who should do what. So a best practice that we strongly recommend is that you should always have on these calls, and when tackling a major incident, an incident commander, which is kind of like the general, the person in charge of the response efforts. So their role is to coordinate the effort, to divide tasks, to assign tasks to individuals, and to avoid consensus decision making that takes a long time. So this it's a bit like this is a wartime situation, quote unquote wartime.
Yeah, crisis.
In that it's crisis. You have time is of the essence. You might be losing revenue.
Right.
So quick decision making is really, really important.
Right.
So this is why you want one person in charge, one person that can delegate actions to other people on the call, to the subject matter experts on the call, and one person that's the ultimate decision maker. That doesn't mean that they have to make all the decisions. They can ask the folks on the call about what's the best recommended course of action. Okay, we're going to do this action. Are there any strong objections to doing this? So people can speak up if they think this is a bad idea, and then moving forward with that action, and then reporting back on the results. So this happens a lot on these incident conference calls that we see. Is incident commander, quick decision making, actions get taken, results get reported, and then you kind of start again if the incident is still ongoing and still not resolved.
That gets into a lot of integration issues, doesn't it? Like,
yeah.
I
mean, it's one of the big issues is getting the context, getting. So, for example, if you're doing something on the USSH into a box, you're running commands in a certain place, getting the results of what you just did back into the conference call. So we see a lot that engineers will paste graphs from monitoring tools, will paste log lines from their logging solution right into the Slack channel, so that other folks can see it in real time.
So Slack's a major integration. What are some of the other? There's lots of integrations that you have, and that kind of like feeds into the platform, doesn't it? And that kind of brings out the robustness of the PagerDuty platform and the API.
Yeah, so we have over 300 integrations today, and a lot of them are integrations with tools like monitoring systems that will generate the events and alerts. We also integrate with collaboration tools like Slack, and with ticketing systems like ServiceNow and Jira.
Right.
We see a lot of, in typically larger companies, you'll have teams that live in ServiceNow that use the help desk tool, and you have other teams such as DevOps teams that live in PagerDuty, and they don't use ServiceNow. So being able to sync the two and have the same data show up in both tools is really important, because now you're tearing those silos between the two teams that are using different tools.
So when you're thinking about, you talked about kind of like what it can be like when 100 people are on a call, right? And how you need that kind of that asynchronous communication, because you can't have everyone on a call trying to solve a problem because it'll never get done, right? You'd be on the phone till 2 a.m. and still not get anything done, right? So, you talked about this cornerstone of team collaboration is having that person in charge, right?
Yes.
And so you really need to have that. So how is PagerDuty helping in that process? Is it through these integrations and then through the API that PagerDuty provides?
Yeah, so we our tool or our platform, we basically aggregate all of the alerts and events from all of your monitoring tools, and then we through our event management, event intelligence functionality, we filter out the noise. So I talked about some of the non-actionable alerts. You don't want those. So filter out all the noise. Automatically group related events and alerts together. So I'll give you an example. If you have a major incident or major outage, you may have lots of different tools, monitoring tools, detected and reported all at the same time. And it's all the same issue. It's all correlated. It's all related to together. So our event intelligence functionality will automatically group that and group all of those alerts and events into a single incident, and then we'll understand the surface area of all the affected systems, and we'll make sure to page out to all the teams that own those different systems. So we actually have a mapping in our system. This is pretty core to what we do, of the systems and the people. Who owns what? Which teams own which systems?
So we're a workflow orientation.
Absolutely, and orchestration. So when you have one of these major incidents, we get all the right people on it, and then we help them streamline the collaboration and communication. So we plug into Slack for the war room. We'll have the functionality to spin up a conference bridge or something like a Google Hangout or Blue Jeans or any of those. And then once the incident is actually resolved, we can automate the creation of the postmortem as well.
Automate the creation of the postmortem as well. Wow. And you must be seeing a lot more companies these days who have these larger teams. I mean, we talked to Vodafone earlier, right? And this has to become part of the kind of the thinking, isn't it? To think through, like, how do you build out these architectures? How do you build out these monitoring services? So they have to really focus on that.
Yeah.
I'm curious about internally at PagerDuty, how have your views evolved as it relates to incident response in kind of your own process that you've been going through over the past few years as you've scaled?
Yeah, it's a great question. So just one, I should mention this, that we've actually documented our process for incident response, and we've open sourced it, so anyone can access it and adapt it to their own teams. It's available at response.pagerduty.com.
Okay.
And there we talk about the different roles involved in an incident, such as the incident commander, which I mentioned, the scribe, which I mentioned, the kind of the note taker.
Yeah.
One thing that's evolved over time for us has been being able to respond to incidents that are long running and that involve lots of different teams. Sometimes you will need to have, maybe because of the scale and surface area of the incident, you may have to have 2 or 3 efforts going in parallel. Like, for example, one team's going to work on, or one subset of the team is going to work on trying to do a database restore, just in case that becomes the preferred solution. And another team's going to actually try to resolve the issue ongoing and debug that. And then you may have a third effort as well at the same time. So you may have 3 different parallel efforts, and once one of them bears fruit, you may decide to execute and go down that path. This is all in order, for the purpose of shortening that incident downtime and incident resolution time.
Huh. And so the shortening of that incident resolution time is key to your mind. Where does event intelligence come into that for you? Where do you start thinking about it?
Yeah, I mean, the event intelligence is all about being able to filter out the noise.
Yeah. So
all the non-actionable alerts. And when you have one of these larger incidents where multiple systems are affected, so remember, in a microservices environment, you can have a whole bunch of the nodes go red all at the same time. And you want to understand the dependencies between the nodes so that you can quickly pinpoint or try to guide towards what's the real problem here, which system is causing all of these alerts and errors to happen. So if you see all the nodes that are lighting up red and you can see the dependencies between the nodes, you can realize, oh, this is probably where the problem is happening. This service is causing all these other services to error out as well. So let's start here. And let's debug in this part of the system, because as I mentioned before, as the complexity of these distributed systems grows, it's too hard for a single person to understand it anymore. So now you have to have software to automate the solution, and that's where we come in with event intelligence.
That's so true, isn't it? I mean, I've increasingly been thinking about how these incident responses have corollaries to what you can view, right? What's visible to you, and and you think about all kinds of things, like you don't know what's around the corner until you get around the corner, right? You can see what's around the corner, right? But you need to have some kind of a idea of understanding what you might encounter as you come around that corner.
Yeah.
That seems to be kind of the core thing with the principles we're starting to see emerge out of DevOps, and is like this visibility, this capability to be more visible, to be able to observe things better.
Absolutely. One of the other things that we've seen, and going back to incident response best practices, is that you have almost 2 parallel responses during an incident. You have the technical response, which is all of the generally engineers who are working together to resolve and fix and debug and troubleshoot and look around all the different systems and actually fix the problem. And you also have a business response at the same time, where how does the business respond in this case? And that involves letting your customers know that there's a problem, usually by updating your status page. If you have high value customers that you have important relationships with, you may want executives at the company to get on the phone and call them and let them know, hey, we're having an issue, a service degradation, service outage right now. So that business response is really important, and that involves letting folks from around the business that are not necessarily engineers, such as marketing or any of the customer-facing teams, such as sales, support, customer success, or the executive team, know that there's an issue. Let them know what the problem is, what the impact is. Do we have a estimated time for fixing the problem or not, and so that they can communicate this to the end customer. And then at the same time, marketing may need to act. Like if you're running email campaigns or something like that, you may want to put those on pause, or social media campaigns, put those on pause while you have this incident, because you don't want to start sending like cheery automated emails to your customers while they're down, for example.
No, that's a pattern that I would think you'd want to avoid. I would like to just kind of conclude with kind of thinking, asking you, what is really exciting to you these days? I mean, it's a time of real change where we see these application architectures have truly evolved. You were talking on stage, the PagerDuty meeting, like Jen in particular, talking about cloud native architectures. What are some of the things that are really getting exciting to you about kind of the future of kind of DevOps, really, and how this and kind of the advances that can be made to make this work easier for people so they can manage at scale? Because there's going to be more companies out there, more and more, that can be doing this. Absolutely.
So what really excites me these days is automation, but automation powered by AI and machine learning.
Yeah.
That's where our new event intelligence product has machine learning in terms of being able to do pattern recognition. Right. So the way it works is you have an incident that is ongoing now. Let's look in our history and see, have we seen this type of problem before? Have we seen incidents that are similar to this one before? Have we seen an event pattern or a pattern of events that has come in that's similar to this one that we're encountering now? And then if yes, what happened last time?
But having that state and understanding what that state was is really complicated, isn't it?
It is. I mean,
it's not just like state is sitting on a shelf somewhere, right?
Exactly. So this is where the work done by our data science team and machine learning team. Yeah. It's some of it goes above my head. For sure, because it's actually pretty complicated how it works, and these machine learning algorithms, how they actually learn based on the data set that we have, and we've been at this for over 9 years now, so we have 9 years of data. So we have a bit of a competitive advantage in this space, to tell you the truth, which is we're in a fortunate position. But this is what really excites me now is using and leveraging machine learning and AI to automate more of this and to filter out more of the noise and to let the responders, both on the technical side and on the business side, focus on the work that really matters.
Well, you have a great team behind you, and so Jen was talking about kind of how much focus that the organization is on the team and the people, and so I think you guys are in a pretty good spot here, can you be able to think through how these teams are going to continue to have to evolve over time, no matter what kind of organization you are. Alex, I want to thank you very much for taking some time to talk with us today.
Yeah, for sure. It was my pleasure.
Great. I'm Alex Williams, founder and editor-in-chief of the New Stack. I've been joined with Alex Solomon, CTO and co-founder of PagerDuty. Thanks, Alex.
Thank you.